Okay, this chapter 9 builds off of chapter 8 very closely. We're going to be learning about trigonometry, but trigonometry is only based on similar right triangles. Okay, so just a broad overview of how this is going to apply before we get into the specific examples you'll be using for 9.1. If I have two right triangles that are similar, which means I've got some angle on this one that's the same as the angle over here, okay? Because that would give me angle. I'd have the right angle, and I'd have this congruent angle, which would guarantee that these angles would also be the same, okay? So I've got these similar right triangles. So if we look at some proportions I could set up, in this triangle, I could put a over x, because they're related. I could also put a over b, okay, because they're related because they're inside, they're from the same triangle, and this would equal x over y. Okay, so this side over that side creates some fraction, and x over y creates the same fraction, and I could have 1,000 different right triangles that all had these same angles, and I would get this exact same fraction every time. So the deciding factor on what that fraction is the measure of this angle. Because if that angle is the same, I'm going to get this same number every time. Okay, so if you want a more concrete example, if this was 3 and this was 5. So if this was 3 and this was 5, the ratio of this side to this side would be 3 over 5. And that would only occur on right triangles that have whatever angle this happened to be. Okay, I don't know what it is, but if we call this angle alpha, okay, any other right triangle that has angle alpha is also going to have a 3 to 5 ratio between the sides that are across and adjacent to this angle. Okay, so that's the basis of trigonometry, and that's what we're going to start building on. Okay, but before we get into that, we're just going to it's kind of a review of symmetrical triangles or similar triangles, and you're going to see a lot of pictures that look like this. Okay, I've got one big right triangle here, and then I've got an altitude coming from the right angle to the hypotenuse, and what this does is creates two more right triangles. And if we look at, let's look at the whole triangle compared to this blue triangle here. Okay, they both have a right angle, and they both share angle A up here, so they're similar to each other. So things that I could write from that. AD would be the short side of the small triangle, and AB is the short side of the big triangle. So those things would be related, and I could put those in a proportion together. DB would be the long side, or the long leg. BC would be the long leg. AB would be the hypotenuse of the short one, and AC would be the hypotenuse of the long one. So if I'm looking for a missing piece that's on this small triangle, I can use these ratios and set up some proportion that I need. So if I needed to know what AD was, okay, I would use this piece and one of these other pieces and get a proportion. Now let's look at the green triangle here. Okay, it is also similar to the big one because they both share angle C. Now, since the blue one is similar to the big one and the green one is similar to the big one, that means they're similar to each other. Okay, so that means I could put any hypotenuse over any other hypotenuse, because those would be related because they're both hypotenuses. Or I could put a short side over another short side, or a long side, or short leg or long leg over another long leg. Okay, so these are ways that you're going to be setting up your proportions to solve for missing pieces. Another relationship you could have is, you know, a piece from the green triangle can go over another piece from the green triangle. A piece from the blue can go over another piece from the blue. But then you'd have to have short sides across from each other, long sides across from each other. So, if we were just to make up an example here, let's make this 8. We'll make this 3. And let's have this be 10. Okay, and let's say I'm looking for the altitude length. Well, 3 is the short side of my small triangle. X is also the short side of my green triangle, so I can put those things together. Okay, X is the long leg of my blue triangle, so I can put that across from 3 because they're both from the small triangle. And 10 is the long leg from the green triangle. So these are related because they're both from the green. These are related because they're both from the blue. These are both short sides. These are both long sides. So I can cross multiply and get 30 equals x squared. So x equals the square root of 30.